Series circuit rules. So what we're going to take a look at is the series circuit here. So the first thing I'm going to do is I'm going to draw a series circuit up here, okay? And I'm going to put a voltage source over here, and I'm going to put 3 resistors here, and I'm going to put those in series. And this is in series because there's only one path of the electrical current to flow. And it's going to go through the resistor 1, resistor 2, and resistor 3. So each one of these resistors is going to have a rating for the load in ohms. So this is going to have an ohms here, and this is going to have an ohms here, and this will have ohms here, and they'll likely be different, okay? And so this would be my resistor 1, and my resistor 2, and my resistor 3 are my loads, okay? Each one of these is also going to have a current that passes through here, okay? And each one is also going to have a voltage that passes through these, all right? So each one's going to have voltage, current, resistance, and finally, each one's going to have power coming through here, okay? And so these will be depicted by, you know, with a little 1 there, P1, P2, P3, P4, P5, etc. Same with voltage, would be voltage for your 1, voltage for your 2, voltage for your 3, etc. So that's the way that R1, R2, R3 work, V1, V2, V3, etc. That's going to be your nomenclature there, the way that you depict it. So the circuit rules, here's the circuit rules, and we're going to draw these mathematically as well, okay? The current is the same at any point in the circuit, which means that the electrical current leaving the voltage source is going to travel through this load and this load and this load. There's nowhere else for the current to go. So we want to write this mathematically, number 1 right here. It says the current in I1, which would be I1 right there, is equal to the current in I2. I2 is there, which is equal to the current in I3, which would be here, and etc. And it would be all the way up to IN, the number of loads that you have. The current is going to be equal in each case, okay? Number 2, the sum of the voltage drops of the resistors must equal the source. So my source right here, you know, this source might have 120 volts or something like that. And then each one of these would drop voltage, and the sum of that voltage drop would equal to be 120. So what does that look like mathematically? That means that the total voltage, which is what is shown here, voltage total of 120, is going to be equal to voltage 1 plus voltage 2 plus voltage 3 plus, you know, as many as you go, voltage n being the number of loads. But these would just all add together. So in this case, 120 volts would have to be equal to V1 plus V2 plus V3. Those are our 3 loads. All right, so that's mathematical there. The total power is the sum of the resistor's active power. So the total power, so once again, this circuit over here is going to be generating a total power here, and the power total is going to be equal to power 1 for the first resistor, plus power 2, plus power 3, plus, you know, up to as many loads as you have, okay? So this power, we're just doing a resistor bank here. This is all going to be dissipated as heat in our situation here, but that's mathematically number 3. And number 4, the total resistance is the sum of the individual resistors. So in a series circuit, resistance adds. So what does that mean? That means that resistance total is going to be equal to the first resistance plus the second resistance plus the third resistance plus as many resistances as you have for your loads. They would add up, and that would give you your total resistance. So that is the mathematical depiction of these series circuit rules.